Hello everybody, good afternoon. We are going to spend a day talking about solving equations using natural logarithms, or natural logs. In Algebra 2, trying to remember, might not have covered natural logs because of the whole pandemic closing us partway through March. It's usually one of the last things we cover. But you might have covered logarithms as a way of solving exponentials, but chances are you don't remember, so it's okay. So it's really hard to explain what logarithms are. I'm not even sure I know, but I know how to use them in math. And one of the most important logarithms is the natural logarithm. The natural logarithm is abbreviated ln. That's what you'll see. ln. Either one. Okay? So ln means natural log. And the way you use it is you take the natural log of a number. Okay? So natural log of 5 is something, right? Natural log of 13 is something. I don't know what it is. It's not something that anyone figures out with by hand. Natural logs you would always do in the calculator. Okay? But that's what natural log, that's how you use a natural log. The verbiage you'd use is take the natural log of a number. Okay? Now, there's a special number in math, and it's called e. So probably you all know about pi, right? Pi is this symbol, but even though it's just a symbol, we know that it means or is equivalent to the value 3.14159, etc. Okay? E is a lesser known same thing. It's a symbol, in this case it's a letter, but it actually has a value in math, which is approximately 2.71828. And just like pi, it actually goes on forever. Okay? So just like pi is a symbol, but you know it has a value, e is a symbol, but it actually has a value. So we're going to be using e today, and I want to make sure that you're clear that e is not a variable like x or b or y or whatever. E is a number, 2.71828. So I'm going to write that up here. So the special thing about e is that natural log of e equals 1. Okay? Natural log of e equals 1. And because of that, we can say that natural log and e basically cancel each other out. So if you had e to the power of x equals 5, you could, and you want to say, how do you solve for x? That's something we haven't covered yet in this class, is how do you solve for x when x is an exponent, or up here in the exponents area? Well, that's where logs come in. If it's e to the power of x, you take the natural log of both sides, because you always got to do the same to both sides, and ln and e cancel out, and you're left with x equals natural log of 5. ln and e cancel out because ln of e equals 1. So essentially it's 1 times x, which, 1 times x is just x. So, I'm not sure how linear this is being, but basically we've got these new concepts, right? Natural log and e. And they are opposites of each other. They cancel each other out. Natural log of e equals 1. So that's why we use natural log to solve problems where x is in the exponent. Because any problems with e generally has an exponent. E is usually written as e to the power of something. Okay? So we can use natural log as an operation to get to x when we have x in our exponent area. Okay, so I'm going to do some examples. It's essentially just like, you know, in our inverse operations, inverse ops, right? We've got, you do minus to cancel out plus, you do plus to cancel out minus. I tried to combine two division signs. You do division to cancel out multiplication, you do multiplication to cancel out division. You probably know by now that we do square root to cancel out square, and square to cancel out square root. And essentially what we've got now is just another thing to add to that list. If you have e to the x, you use ln to cancel it out. If you have ln, you use e to the power of to cancel it out. Okay? So, these are just two new inverse operations that we've learned. Okay? And we got to fit them in with everything else we do. So, let's just start this. If we have e to the power of 8x equals 46, and we want to solve for x. So, we need to follow how solving does order of operations in reverse. We can't get into this 8x, we can't do this natural log until we get rid of everything outside of the e. So 2 is not part of my e to the power of thing. Okay? So we can't take the natural log of both sides until we get rid of this 2. So right now it's 2 times e to the 8x equals 46. So how do you get rid of times? Divide. So e to the power of 8x equals 23. Now we've got our e term by itself. That's when we take the natural log. So I'm going to take the natural log of both sides, however you want to write it. I could write it the whole thing again like this, I guess. Okay. And the purpose of doing that is ln and e cancel out. So now you only have whatever's in the exponent. 8x equals natural log of 23. I don't know what the numerical value of natural log of 23 is. I don't care. I'm not even going to worry about it. I'm just going to keep writing it as ln of 23. So now you just have 8x equals ln of 23. What's the last step to get x by itself? Divide by 8. So my final answer would be x equals natural log of 23 over 8. And it's okay that I don't know what that number is. I know that's not very satisfying, but point is you got x by itself. If you were typing this in, it would be ln of 23 over 8, the keyboard. So, that is your answer. X equals natural log of 23 divided by 8. Hopefully that sounds good. All right. What if I had x2 e to the 3r plus 4, 5. E to the 3r plus 4 equals 55. Okay? So, remember, we can't deal with the e till we get rid of everything outside of the e term. In this case, that's 4. So how do we get rid of the 4? Minus 4. Okay? So e to the 3r equals 51. Now we've got the e by itself. what do? Take the natural log of both sides. ln and e cancel out, and we get 3r equals ln of 51. Not too bad, right? Pretty straightforward solving stuff. Last step to get r by itself, divide by 3. So what you end up with is natural log of 51 over 3. And again, I don't know what that value is. I don't care. We got r by itself. We did our job. We good. Okay. Third example. Oh, whoops. I almost wrote one of the problems. Okay, here we go. So, negative 8 e to the negative p plus 1 equals negative 48. Nope, it's not supposed to be. Sorry. Okay. Negative 8 e to the negative p equals negative 48. So, first step. We can't deal with the natural log, or we can't deal with the e until we get it by itself. So what's outside of the e term? Negative 8. So how would we get rid of the negative 8? Some people might say add 8 because they see the minus and they want to do plus 8 to cancel out the minus. But remember, this isn't anything minus 8. It is negative 8 times e to the negative p. So to separate the 8 from the e, we're actually canceling out multiplication between them, not subtraction. So we would divide by negative 8. 6. Okay, a negative divided by a negative is a positive, and 48 divided by 8 is 6. All right, now we've got our e term by itself. We're going to take the natural log of both sides. Okay, negative p equals ln of 6. And what can I do to get this to just be p? Okay, so this isn't solved yet because it's not p, it's negative p. So you could call this a couple different things. We could say multiply both sides by negative 1. We could say divide both sides by negative 1. Either one works. Personally, I just say if negative p is positive ln, then positive p is negative ln. You can just switch the negative signs, right? You just have negative term equals positive term, then positive term equals negative term. So switch the negative signs, and you've got p equals negative ln of 6. And that would be your final answer. So, I hope that this is not so bad. I have just a few problems for y'all to do, and let me know if you need anything.